Okay, for this example, we're going to do an RC circuit. So the way this circuit is situated, we have a capacitor and we have a switch that's going to open at t equals 0. So we need to find our initial conditions. Okay, so what's going on before the switch opens? All right, so in this case, we know that it has been closed for a long time. All right, that means we've reached a steady state. We also know that we are attached to a DC voltage source. Okay, so our capacitor is going to be acting like an open circuit. So let's redraw the circuit like this. Again, this is before t equals 0. And have something like this. Okay, we know that there is no current flowing through this branch since it is behaving like an open circuit. And so in order to find VC, we can use voltage division or KVL to find what our VC is for our initial condition. So this would be minus 10 plus 3I plus 9I equals 0. Okay, and we're going to solve for I. We find that it's 5/6 amps. Now if we find what our voltage is across our 9 ohm resistor, it's going to be that current times 9. And so our voltage will be 7.5 volts. Again, this is VC 0 minus. Now, the thing that we know about capacitors is that the voltage cannot change instantaneously. So immediately after our switch is opened, okay, we have not reached steady state. There's something happening. VC of 0 plus is just going to be our VC of 0 minus, since our voltage across the capacitor cannot change instantaneously. All right, so now we want to look at what's happening as t approaches infinity. All right, so now our switch is open, so there's no source connected to the right-hand side of the circuit, so there's no voltage flowing, okay? So VC infinity is going to be 0, okay? So now we have what's happening before the switch changes, what happens immediately after the switch changes, and what's happening with the voltage across the capacitor as t approaches infinity. So now we want to figure out our time constant, which is going to govern the speed at which these changes are happening. All right, so tau for a capacitor is R times C. So we know that we're looking for our R equivalent, and we're going to multiply that times C, which in this problem is 10. All right, let's find our R equivalent, which is essentially RTH. All right, this is after the circuit has an open switch. All right, and we're looking through the terminals of the capacitor. Okay, so since it is open switch, there's no current flowing here. So we can ignore this 3 ohm resistor, and we can add the 1 ohm resistor and the 9 ohm resistor in series here. So 9 plus 1 is 10. Okay, so this is our equivalent. So to find tau, we just want to multiply that 10 times the capacitance. So our time constant is 0.1 second. All right, so we're going to put this now in the standard form. All right, where we're looking at our final conditions and our initial conditions and everything in between. And we will say all right, so our equation for VCT is going to be 7.5 e to the negative 10t volts. Okay.